Hello, lovely folks. Thanks so much for. Yep, that's all right. Thanks for pointing this out. Thanks so much for the very warm invite. I'm actually standing here before you because I have great news to tell you. I'm 100% sure we're facing right now, and actually we're sort of taking part in a very big change in the front end world. This slide is intentionally left blank. So where were we? Yeah, this is a very big moment, and we actually realized this as we sat. It was last week at the Lystable London office. We talked about the hiring strategy, and someone brought up this tweet. Take a while to read this. It's basically about WebAssembly. Who of you guys has heard of WebAssembly? Cool. That's quite a bunch. For those who haven't, WebAssembly is something that came into existence. I think it was like 2 years ago when Brendan Eich, the very creator of JavaScript, he decided that JavaScript is sort of becoming some kind of bytecode. So why not enable engineers to run other to run JavaScript as actual bytecode, as binary code, which is compiled from other languages, and this is since it was announced that they're working on this, it has been a sort of very distant future, a very distant like moment when the paradise comes to us. But it turns out with this tweet, we actually see that all of the 4 major browsers, which is Chrome, Firefox, Internet Explorer, and Safari, all the 4, they're already all set to switch WebAssembly on by default. And what this effectively means is that it might be 2 weeks, it might be 3 weeks time from now, but the moment is approaching when we will be able to write any language and run this in the browser without the interpretation step. So I've been speaking with Richard Feldman, an influencer in the Elm community, about this as well, and I'm just telling this so that you realize how big a moment this is. He told me that on the roadmap of Elm, Elm is going to be a language which is for enthusiasts and people who prefer functional programming until WebAssembly hits the scene. Because when WebAssembly comes, it will enable Elm to effectively outperform any native apps. So take a moment to sink this in. Elm, which is running inside a browser, will be able to outperform native apps. And why is that, you might ask? The reason is Elm apps are structured in such a way that multi-threading is a sort of the default. So you can shift all the business logic outside of the view layer, and have the view layer, sort of the layer which is most important for the application to be smooth, only be responsible for the application being smooth. And any other calculation, so all this stuff, which I'm pretty sure everyone knows this feeling, having an old phone or sort of using an old phone and scrolling through a website, and suddenly a website grinds to a halt because there's some calculation going on, and then you can resume this. And this happens not only to websites but also to native apps. So yeah, WebAssembly is coming, and this is in this talk I'd like to highlight this, but this is sort of one of many factors which I'd like to point out today. I'd like to tell you how to not only to survive in this new world when we can run any language in the browser, but also to sort of make the most out of this and really sort of go down the slope and with the current. So let's start with a story about how relevant this is for Lystable. So we've been facing two problems recently, and one of them is a scaling problem. When I joined Lystable it was about eight months ago, we were a team of 6 engineers. So it was a pretty nice and cozy little team. What's up? Yeah, this slide is intentionally left blank. Where were I? Yeah, so when I joined Lystable, we were a bunch of 6 engineers moving crazy fast because everyone knew what he was doing, what she was doing, and we were sort of our own bosses. But since then, I actually counted this. We've had over 30 people join the company, and most of them were engineers and designers, so product people. This means there's a new person joining in every week. This is really insane. This speed at which we're growing the company, and you can imagine at this point, it's really hard to sustain this pace because people need to be ramped up to get to know the code base. The code base has meanwhile grown to almost 200,000 lines of code on the front end itself. So it's pretty challenging to have new joiners get to know the code base. And the other problem is we basically started to avoid refactoring because refactoring often means weeks or sometimes even months of sitting there and having the sort of top engineers who have the only ones who have an insight into all of the code base work on this to just introduce new patterns. And this is a moment when we realize this African proverb. I'm not sure, perhaps you've heard of this. If you want to go fast, go alone. If you want to go far, go together. But at Lystable, with the fast-moving market, the only option we have is to go fast and far. How to do this? This is a very big question. So this is the scaling problem, and the other problem is also related to hiring, where we actually we've noticed that the React market in London and in San Francisco, where we have our offices, is pretty thin. And what I mean by this is there's loads of companies having React engineers, and when there's a good React engineer, they're doing everything to keep him or her. There's sort of the market sucks in every good React engineer. But the situation is different in other technologies, especially emerging ones like Elm or Vue.js or on the back end Elixir. So these are sort of technologies where brilliant minds are really looking into this stuff, great engineers, and they're finding it hard to find a job because the technologies are new. So the only real players on the market are very new and small companies where it's also difficult to get a job. So this is a market we also want to address somehow, but we're also not ready for a move like refactoring all of our code base into Elm. This would be insane. So how to solve these two things? And so the backend team has started dealing with both of these problems by developing new features as microservices. But there's no such thing as microservices on the front end. By the way, who of you guys has heard of microservices? Wow, almost everyone. Cool. Ask who's... Ah, yeah. And who of you is capable to raise their hands? Oh, so there's more people knowing what microservices are than there are those who can raise their hands. Cool. And the other question I wanted to ask: who of you is aware what web components are? Cool. Web components are. This is also an emerging specification for creating your own elements. Like you've got a a div in the browser, you've got a button, so you create your own like video tag, which is playing a video, or a slideshow tag, which takes a couple of images and creates a slideshow. So this is the sort of traditional way to understand and explain web components. But we looked at those two technologies because we realized they're very closely connected to each other, and we realized that you can actually. But by the way, this slide is wrong. So if you posted it to Twitter, then just delete that tweet, because there's no such thing as microservices on the front end. This doesn't make sense because services is something very specifically backend, and web components is also a very sort of broad topic. We're only using a very like one fourth of that specification, which is custom elements. So the real way to say it is use custom elements to connect micro apps into a single experience. And micro apps is the answer to both of these problems. So basically, we figured if we develop our platform, our experience, not as a single monolithic app, as it normally happens in the React world, and this is very scalable. Don't get me wrong, but this creates these other problems which I mentioned in the beginning. But instead, invest the time into defining very little tiny focused apps which communicate with each other and guide the user through a single experience, so that the user doesn't really notice that he or she is actually using 2 or 3 apps or 5 apps or 7 apps, but inside a single experience. And now the moment everyone has been waiting for, which is the demo. So there we go. We like to experiment before we implement any real stuff in the code base. So here's an experiment we made to a proof of concept whether this stuff really works. So this is basically a presentation timer. I needed a timer to tell me using colors where I am and where I should be in the talk. And as a sort of testing ground, we decided to not to write this as a single app, but to write this as 3 different apps. One of them in React, one of them in Elm, and one of them in vanilla JS. And here's what it works like. So we define what color the timer starts with. Then we say after 2 seconds pass, let's change the color to teal. And after 5 seconds have passed, we change the color to black. And at the start of the talk, we're ready to roll. And there we go. We've started with the orange. At the second second, it's turning into teal. At the third second, it's turning into black. But in reality, this is not a single app. These are 3 different apps interacting with each other. And those could very easily be developed by 3 teams completely independent of each other. So sort of 3 little startups inside a big company, yeah? So where each of these startups can move really crazy fast because they've only got these 2 or 3 or 5 engineers who understand each other perfectly, and everyone is using the technology they feel best in. So there's our timer ticking away nicely, and let's look very briefly under the hood of this stuff. So this is our HTML structure. If we pause the timer for a while, we can see the custom element. So you remember me telling you what web components are? That these are custom tags, and this is a custom element which has sort of all of the logic of the timer display baked in. This one is, oops, sorry for that. This one is written in Elm, and now when we look into the control panel, we can see timer controls. So this stuff here on the outer, we call it the app shell. The app shell is just vanilla JavaScript and HTML, but this part which is interactive, timer controls, this one is written in React. And now the fun thing is we can well, the way they communicate in this proof of concept is through HTML attributes and events. So if I update the initial color to something crazy like magenta, magenta is red, no green, and blue. There we go. The initial color is now set to magenta, and well, the inner app, the micro app inside, it understands everything perfectly. And now have a look at this. The micro app actually told the timer display that the default color, the initial color, is magenta. We didn't need to. This sort of got routed through the app shell into the timer display. So the timer display team doesn't need to know where this value comes from, whether this is from someone hacking away like we are trying to break the app, or from one team or from another team, or completely from the external world, from the URL. I don't know. But the only thing they care about is their own little world inside their app. Yeah. For the while, we can also change the last color to vivid green. The most beautiful. Oops. No, that wasn't. Okay, never mind. You can. Let's do this on another attribute. If we get rid of the pause attribute and fix the breakpoints thing, then we can see that it's not pause anymore. And now when I add the pause attribute again, this is the Elm app again, listening to all our stuff. Then it gets paused. So the gist of it is, you don't care about the whole app. You just focus on your little sort of very little and cozy area of expertise. Yeah. So if anyone's interested, I can also walk you through the apps, the micro apps themselves under the hood, what the Elm app looks like, what the React looks like, what the React app looks like, what the app shell looks like. But now let's get back to our presentation. There are also two. Wait. Thanks for waiting. There are also two other stories I wanted to tell you very briefly. So the first story is a side project I'm doing after hours right now. Perhaps in a couple of months or a couple of years' time, it will turn into a startup. But the fun thing is, the team we're hacking away on this startup with. So basically, it's two of my friends from university, and one of them is actually a university professor, one of those really crazy professors. He's a professor of electronics, and he's working as a professor of architecture. So he's also a sort of hacker. So it's basically this guy. So we've got very different backgrounds, and each of us sort of knows something else from front-end development. So if we tried to consolidate our patterns, the technology, it would be really hard. So basically, each of us works on their own. We're also a distributed team working after hours, so it's not easy to sync. Where each of us is working on their own and on the micro apps, and we just wire the things together, just like we saw in the demo. So for a very tiny team, it also somehow works, brings some benefits. There's one more story I wanted to tell you from my previous team. I worked for full time. We worked for a system for an internal system for managing projects and employees at Volkswagen. And the system was basically somewhat like a web-based OS. So it's like we only provided the framework and the sort of the Chrome, the Windows, the controls, the buttons, and other engineers from very different companies who we couldn't communicate with in any way other than documentation. They wrote applications which ran inside this web-based operating system. So first off, we experimented with iframes, which is the sort of go-to way to embed an app inside another app inside another app on the web, but this introduced many different problems. And this is something that Spotify also tried to do. Nowadays, Spotify is looking really lovely and consistent, but in the early days, I don't have a screenshot, unfortunately, but in the early days, they admit themselves that each of these areas in the app, they were sort of a world of their own. Different fonts, different sizes, different colors, different line spacings, and so on. And that's because they were doing microservices on the front end. They didn't tell it this, call it like this, but they were microservices on the front end. But they did it in iframes, so everything was sort of very wild and on its own. I don't know how they managed to tame this, but the way we managed to tame this is, and this is actually, I think this is the key to success if you're going down this route of splitting down your app into micro apps. And the thing is, you've got these micro apps sort of in a flat structure next to each other, communicating with each other. But the thing is, they need to have a layer underneath them which ensures the styling is consistent. So whenever any of those micro apps wants to render a button, it just takes something from the style guide. It also, if you want to have the freedom to choose any technology you want to keep the style guide as low tech as possible. So it's normally just raw HTML and CSS. That's the way we did it with at B12. And just very briefly, low-tech style guide. This is tweetable again, so take your time to take lots of photos and post them to Twitter. And time for another demo. Very quick one because I'll soon be short of time. This is what I want to close. This is something I want to show you. So sometimes raw CSS and HTML is not enough, as we know, and that's the case if you want to implement your custom select box, the holy grail of web development since the very dawn of it. And there we go. We've created a custom select box which mimics one-to-one as closely as we could get it, the behavior of the native select box in the browser, including keyboard navigation, focus, and all that crazy stuff which the browser takes care of. And well, this is explained in here somewhat. Let's not get into detail. But the thing is, this is again just raw JavaScript and just raw HTML and CSS. An unordered list of lists and checkboxes inside. The fun thing is, it's even though it's a different level on the sort of beneath the micro apps, this again is custom elements. It proved pretty flexible for this kind of stuff. One more fun fact. This way of working with a low-tech style guide also falls back very gracefully in case the JavaScript does not load, or before the JavaScript loads. Yeah, if we're on a flaky connection, the HTML streams in, the CSS streams in, but the JavaScript is stuck somewhat. But look, we've just done it with CSS and HTML, so the dropdown is still usable. The data will still be posted to the server when we click the button. But it's just degraded. It's a bit worse. You don't get the keyboard navigation. You don't get the focus stuff, and so on. So you can do really nice stuff with this stack, even though it's so very basic. Yeah. So we're approaching the conclusion. Basically, the single thought I wanted to sort of plant in your mind so that you become richer when you leave this room. The single thing is, if you want your company to behave not as a big team, if you're working in a big team, but as a sort of team of teams, as a startup of startups, yeah? You know what I mean, where each of those startups has their own goals and has the option to move really fast without being dependent on other teams, then go for the micro apps approach. Thank you very much.